In order to solve this one, we have an angle measurement and the side opposite, and then we have another side. So that means we can use the law of sines, which says that the sine of 34 degrees over 19, the sine of this over this, will equal the sine of angle C, of angle A, the sine of angle A, over 18. The sine of 34 degrees is 0.559 something something something. If we multiply that by 18, divide the whole thing by 19, that gives us 0.529 something something something, and that's equal to the sine of angle A. The inverse of 0.529 something 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 is equal to 32 degrees, and it's also equal, if we look carefully, if this is the sine of 32 degrees, then there's an angle over here where this is 148 degrees and this is 32 degrees that will have the same sine. So let's take a quick look here. Looks like angle A, the measure of angle A will be 32 degrees, but let's see if that works intelligently here. If the measure of angle B is 34 degrees and the side is 19, then the angle across from a side of 18 has to be less than 34. So it can't be 148. That is the answer to that one. And then, in order to get angle C, we have to add up 32 and 34, and that gives us 66. 180 minus 66 is equal to 114. So we need to use the law of sines one more time. And it says that C over the sine of 114 will equal 19 over the sine of 34. We already know the sine of 34. We have that one. So this is equal to, C is going to be equal to 19 times the sine of 114, which we'll get in a second, divided by 0.557 dot dot dot. The sine of 114 is 0.9135 dot dot dot. And if we do that arithmetic, we get 31 as an answer. So, in order to finish out this triangle, this angle is 32 degrees. This angle is 114 degrees. And this side over here is going to be 31 miles. Okay. We have this angle. We have this angle here. We have the side across from it. And we have the side over here as well. So we actually have the same situation here that we did up here. We can use the law of sines. So let's do that. We can say that the sine of 39 degrees over 31 is going to be equal to the sine of B over 33. So the sine of this over this is the sine of this over this. We know that the sine of 39 degrees is 0.629 something something something. Multiply that by 33, divide it by 31, and that will give us the sine of b. When we do that arithmetic, we see that the sine of b is equal to 0.6699 something something something. And that means that the measure of angle B is going to be 42.1 degrees, or at least that's what our calculator says. But keep in mind, if there's an angle here that's 42 degrees that has a particular sine, there's going to be another angle over here that will be the supplement of 42.1 that will also have the same sine. And the supplement here is 137.9. So going back to look at this, is there any particular reason why that wouldn't work? B could be 42.1, and it could be 137.9. In both cases, it would be larger than 39 degrees, which it has to be because the side opposite is bigger than 31. So let's pursue this and see what happens. Let's start with what happens if the measure of angle B is actually 42.1 degrees. Well, 42.1, and we already know C is 39 degrees. So if we add those together, we get 81.1, and that means that the measure of angle A has to be 98.9 degrees. Okay. So again, we need to figure out the side opposite that, so that'll be 31 over the sine of 39 degrees is equal to A over the sine of 98.9 degrees. We already know the sine of 31 degrees, and that is 0.629 something something something. And we can find the sine of 98.9 degrees. That's actually going to be 0.9879 something something something. And when we do this arithmetic here, A turns out to be 48.7. Now, does all of that make sense? Well, let's take a look. The measure of angle B would be 42.1. The measure of angle A would be 98.9. And then the side opposite would be 48.7, and that's reasonable too. The longest side would be opposite the longest angle. Let's see what happens if we try the other angle, 137.9, okay, and see what happens to our triangle. So if we have 137.9 plus 39 degrees, that's going to be 176.9. That means the measure of angle A, it's going to be a small one, the measure of angle A is equal to 3.1 degrees. Okay. So we do the same arithmetic we did over here, and that is that 31 over the sine of 39 degrees will equal A over the sine of 3.1 degrees instead of 98.9 degrees. So we already know 31 over 0.629 something something something. The sine of 3.1 degrees is 0.629 0.05407 something something something. And that's going to be equal to A when we do that arithmetic. And that arithmetic turns out to be 2.7. And so that will be equal to A. So let's see what happens there. If A is really that tiny, if A is really 3.1 degrees, because this is really 137.9 degrees, then it seems perfectly reasonable that this side over here would be incredibly small, 2.7, and in both cases these would be meters, is our solution. So there are actually two solutions to this. Looking at this triangle here, we have a problem. 105 degrees has to be the largest angle of the triangle, because these two together can add up to more than 75 degrees. But the side across from this is 5, and this side over here is 14. This triangle cannot possibly exist. And that's the answer to this problem. There is no such triangle that will make that work. So let's take a look at this one. This one's different. We have two sides and the angle between them. We don't have this side over here, and we don't have either of these angles, so we can't very well use the law of sines, but we can use the law of cosines. The law of cosines says that this side over here squared is going to be equal to this side squared, which is 21 squared, plus this side squared, which is 29 squared, minus 2 times 21 times 29 times the cosine of 84 degrees. So it's a bit of arithmetic to do. 21 squared is 441. 29 squared is 841. And 2 times 21 times 29 is 1218. And we still need to multiply that by the cosine of 84 degrees. So if we add these two together, we get 1282. And this is going to be 1218 times 0.104 something something something. A little more arithmetic. 1282 minus 127.31 something something something. And that turns out to be 1154.68 something something something. And all of these, all the way down the line here, the left side hasn't changed. It's still c squared. If you take the square root of c, you get 33.98 something something something. That's going to be 34. And so going back over here, this side over here is going to be 34. Now we have this side, we have this side, we have this side, but we don't have either of these angles, and we still need to get that. This tells us that the sine of 84 degrees over 34 is going to equal the sine of b over 29. The sine of 84 degrees is 0.994 something something something. If we multiply that by 29, divide it by 34, that will give us the sine of b. and you get 0.848 something, something, something. That's the sine of B, which means the inverse sine of 0.848 something, something, something is going to be the measure of B degrees. We get 58 degrees. That's going to be the measure of angle B. Let's see if that makes sense. Well, this could be 34. These two sides obviously have to be smaller. This could be 58 degrees. And if that happened, then 58 plus 84 is 142, and 180 minus 142 is 38 degrees. So this would have to be 38 degrees. And again, this side would be smaller because this is the smallest angle. So it would be small, medium, large, small, medium, large. And that actually works out. Finally, we have this question here where we have the side lengths, but we don't have any of the angles. That's okay, we can still deal with that because let's pick this one, for example. The square of this length is equal to the square of this length plus the square of this length minus 2 times 18 times 17 times the cosine of whatever angle C is, whatever this angle here is. So that's the arithmetic we need to do. This side is 900. 18 squared is 324 plus 289, that's 17 squared. Okay. Minus 612 times cosine of C. So if we add these together, we get 613. If we subtract 613 from both sides, we get 287. If we divide both sides by 612, we get 287 minus 287 over 612 is equal to the cosine of C. This fraction becomes negative 0.4689 something, something, something. That's the cosine of C. And in order to get angle C, the measure of angle C is going to be equal to the inverse cosine of negative 0.4689, there we go, the inverse cosine of this number. And that turns out to be 118 degrees. If C is now 118 degrees, now we have enough information so we can use the law of sines. The sine of 118 over 30 has to equal, let's take this one, the sine of B over 18. Now the sine of 118 is 0.8829. We'll need to multiply that by 18 and divide the whole thing by 30 to get the sine of B. That number turns out to be 0.529 something, something, something. And if we take the inverse sine of that number, that will give us the measure of angle B. In this case, it turns out to be 31.98 degrees, or if we're rounding it to the nearest tenth, which is what it said to do, it's going to be 32 degrees. So the measure of angle B is 32 degrees. Let's see if that makes any sense. Well, let's see. This is across from the largest side. This is across from the next largest side. So we need to see what will happen if we add these together. Will this angle be smaller? If it will, then that'll all work out. 118 plus 32 is equal to 150, and 180 minus 150 is equal to 30 degrees, and that actually works. This is just slightly smaller than this angle, and this side is just slightly smaller than this side. So again, we have it working out just fine.